Hi, it's Robert Naini, your spray foam advisor. And from time to time, I get questions about thermal bridging and exactly what it is and how does it affect our buildings. And as spray foam contractors and spray foam professionals, how do we manage it and talk about it out there in the industry? So let's talk about today thermal bridging. So what is thermal bridging? Well, you're familiar with thermal performance and R value and how energy or heat transfers through building materials. That's actually what R value is. It's resistance to heat flow. And so thermal bridging describes the phenomena that occurs when you have dissimilar materials with different thermal rates of transfer, so different R values near each other. And when you have different materials with different R values next to each other in the same assembly, then the rate that the heat transfers through one of those materials is going to be much faster in some cases than the material right next to it. So we'll take, for example, the most common case of thermal bridging, and it's when we insulate steel studs or metal studs. And when we insulate metal studs, the metal transfers heat much faster than the insulation that goes inside the cavity. And so the result of that is the overall thermal performance of the wall assembly is actually pulled down because the thermal transfer through the metal studs is so high that it degrades the performance of the overall wall system. So if we put an R20, say, inside the cavity of a metal stud system, well, that metal stud, the performance of it is so bad that the overall wall assembly is going to perform closer to something like an R13 overall. So we get a pretty bad degradation. And that's not exact. Don't quote me and try to find the exact science on that because there is information out there, but those numbers are just kind of ballpark guesstimates of what's going to happen in the derating of that system. It's not going to be 100% exact in that example. Now, how do we overcome this? The code has actually moved to continuous insulation, and we're moving more and more towards continuous insulation to help address this issue and this type of an issue. So on the exterior of a big commercial building that has metal studs or it has a steel frame with maybe CMU built around it, a big way for us to help from a thermal efficiency standpoint is by providing continuous insulation on the exterior of that assembly. And what that does is it mitigates thermal bridging. It helps stop the heat transfer through the insulation before it ever gets to the structural member so you don't have the same type of thermal bridging occurring. So what we're doing in that situation is we're separating that component, the metal that would provide thermal bridging, we're separating it from the heat source or the hot air, the hot environment on the outside, so that it doesn't have the ability to transfer through, for example, in the south during the summer. Now, there's also another opportunity, another time that you'll see this occur. It's less noticeable because it's not as much of a failure, if you will. There's not as big of a difference in performance. But if you look at a roof deck that has been insulated between the rafters, say early in the morning when fresh dew has set, or up in the north, you'll notice this with when there's a thin layer of snow, you can occasionally see the melted lines every 16 to 24 inches on center where the rafters have allowed heat to pass through them and have actually melted the snow or melted the dew on top of the roof. And you can actually identify the rafter marks on a roof system because of the heat that's escaping through the rafter compared to the heat that's not escaping through the insulated cavity. So that's kind of an example of some of the times that you're going to see thermal bridging, how it affects insulation and overall thermal properties. And ultimately, the best way to address thermal bridging is try to eliminate as much as we can, try to eliminate the low R value materials from having direct contact from the inside to the outside. And so that's the purpose behind continuous insulation. In the attic situation where you have where you might see melted snow or melted dew and you can identify where those rafters are. The key in those applications is to flash the face of the rafter on the inside, especially if you're applying spray foam. Put a flash coat over it and it's going to slow down the heat transfer enough that it's going to be much less noticeable on the exterior of the structure. So those are some guidelines and some tips about thermal bridging. Take that information out in the market, share it with your customers, and go out and get more business. This has been Robert Naini with Spray Foam Advisor. Check us out on some more videos.